Problem 17 asks, what truth table column will determine the validity of the argument shown here? Well, if we were to make a truth table for this argument, we would want that the argument itself, which is premise and premise and premise, all together to imply conclusion. That is the structure of an argument. And so in our case, we have a premise here, and a conclusion here. So we're looking for P arrow Q and not Q together imply not P. P arrow Q and not Q together imply not P, and that would be answer C. Okay. Now here we have an argument, and we're asked to not only determine what its diagram might be, but also determine whether it's valid or invalid. Okay, the argument is fairly small. The tire patch will seal the hole, or we will break down. The tire patch will seal the hole. We'll call that statement P. We will break down. We'll call that statement Q. These are simple statements. The tire patch did not seal the hole, so we have P or Q. The tire patch did not seal the hole, therefore we will break down, therefore Q. So in this case, the diagram most matches, well, not this one, matches either C or B. It looks like it's certainly not that one. So the question now is, which of these two is correct? Is the argument invalid or valid? If you happen to look at patterns as a way of validating argument, this is a valid pattern, so the answer should be C. But as an exercise, let's do this with the truth table. Okay? So we have the argument P or Q, not P, therefore Q. And we want to determine whether it's valid or invalid. So we'll do a giant truth table. This is one method, pattern matching is another, and then the bad row is the last technique. And so we'll have certainly P or Q will be one column we'll need. We'll need not P. We'll need the P or Q and not P column. And finally, we'll need the argument itself, which is P or Q and not P together imply Q. And if that last column is all trues, then it's a valid argument. If there's a single false, then it won't be. So again, put in some entries here. Okay, P or Q, that's true, false, true, true. The negation of P's would be false, true, true, false. The anding of these two, or the conjunction of them, would be false, false, true, false. And finally, we're going to take the values here and ask whether they imply Q. So we're going from here to here. False implies true is true. False implies false is true. True implies true is true. And finally, false implies false is also true. And you can see here that it's a valid argument. Okay. Now another way to do that might be this bad row method we talked about. And to look at that technique, we would take our argument P or Q, not P, therefore Q, and we would want to determine if it's possible for this argument to be invalid. Well, if it's possible for the argument to be invalid, then there'll be a case where the premises are true and the conclusion is false. If it is invalid, then this can happen. Okay, so let's check Well, there's only 4 possible values for P and Q. That is true, 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 false, false, true, and false, false. Well, if we're trying to see whether this can happen or not, we can only worry about Q being false. That is, this can only happen if Q is false. So certainly the cases where Q is true, we don't need to worry about. Those will not give us that situation. We're trying to determine if this situation exists. Well, now in the case here, where not P is true, then that can only happen if P was false. So this can only happen if P is false. So we don't need to worry about P being true. And we're left with one scenario. And let's just run through this and see if we can get true, true, false. Well, we start with P being false and Q being false, and we look right off the bat and we see P or Q, our only possibility, cannot happen. Okay. So we conclude that it can't happen. That is, there is no case where this argument is invalid, so it must be that the argument is valid. Okay, so our answer in any of these cases would be C. Now in number 19, we're given an argument. All frogs are amphibians. Some amphibians are green, therefore some frogs are green. And we'd like to determine if this is valid or invalid. I think the best way to do this is to first attempt to invalidate it. That is, we're going to see if we can draw a picture in which this is true, and this is true, and this is false. Can we draw this? Okay. We'll start by drawing all frogs are amphibians. That's fairly easy. There's a set of frogs, and here would be the set of amphibians, set A. And now we want to draw some amphibians are green. So the set of green things would touch the set of amphibians. So we could draw green things like this. We could draw them a little bit larger and touching the frogs, etc. As long as the set of green things touches or intersects the amphibians, we've satisfied the second premise. But in trying to get this to be an invalid argument, we might fail. But in trying to get it to be invalid, we're going to try to make the conclusion false. We don't want that some frogs are green. In fact, we want no frogs to be green. That is, can we draw green things so that it both touches the amphibians but does not touch the frogs? And you can see in this case it's fairly straightforward to draw the green things like this so that it touches amphibians but not frogs. And let's check. Are all frogs amphibians? According to this, yes, all frogs are amphibians. Are some amphibians green? Yes, we can see all we need is one thing there to show us that some amphibians are green. And therefore some frogs must be green. Well, you can see that's not the case here. So we have a bad row. And what we have here is a counterexample to the argument. It's a case where the premises are true and the conclusion is false. And that shows the argument is invalid. Okay. So to choose our answer, we would look amongst the possible answers, and we're going to try to figure out which one it is. Let's see if we can see which one it is. Well, it's an invalid argument, so certainly one of these two. And the bottom two say both valid, so we can ignore those. Those are incorrect. And we're looking for a picture where all frogs are amphibians, and some amphibians are green, but not all. Sorry, no frogs are green would be the negation of the conclusion. And you can see here, this picture doesn't satisfy the second premise. We needed that some amphibians are green, and this doesn't show the argument's invalid because it doesn't have both premises true and the conclusion false. This is the one we want. Both premises are true, but the conclusion is false, showing that that's an invalid argument. And again, we're not even going to worry about these Euler diagrams because they both say the argument is valid, which we know not to be the case. All right, let's look at the next problem.